Good afternoon to all. Open your assignment and see the remedy for all these 6 questions, whatever I have given to you yesterday to solve. So please check your answers. First question was define the following, and you need to give one example at least in support of your answer. Polynomial. First it was asked what is a polynomial. So I said any expression which is like if you are writing the example x cube plus x square plus 1 by 2x minus 3 and so on. So this is a polynomial. You just check polynomial, but if you have written the definition of the polynomial, any algebraic expression in one variable or more with degree 1 or more than 1, with degree 1 or more than 1 in whole number consisting of all four fundamental operations is a polynomial. So in example, you can write any example in one variable or in more than one variable. So first part was polynomial. Second, standard form. So this already I have written in standard form. When the degrees are arranged either in ascending order or descending order, you can write in a reverse order also. That is also the standard form. When we are writing the algebraic expression in terms of its power, either in ascending order or in descending order, then that form is known as the standard form of the polynomial. Then third, degree of the polynomial. So highest power of the polynomial, like here in this example, you can see the degree is equal to 3. Whatever the highest power you have taken, that will always be the degree of the polynomial, and you give the example also. Then constant polynomial. So in constant polynomial, suppose you have written 5, any number, constant number when you are writing, except 0. Please remember that, except 0, that is a whole number. I am asking about the numbers. So any number 5 with positive sign or negative sign, all those are called the constant polynomials. Then fifth part was zero polynomial. So here you have to write 0. 0 itself is denoting a zero polynomial. So this was your question number 1, where you were supposed to write the definition. So constant polynomial means when any number is written, any number, natural number or whole number, but with negative sign except 0. I said do not count 0 there. And in a zero polynomial, only and only 0 you have to write there, which denotes the zero polynomial. Give one example each of the following. This was your question number 2. Quadratic polynomial. So you know quadratic polynomial is consisting always of degree 2. Suppose you have written simply x square plus 1 or x square, or you have written x square plus 3x. So all these can be the example of your quadratic polynomial. Even x 3x square plus 2x minus 1, all these are the examples. So degree 2 should not be missing anywhere. Only x square is also a quadratic, x square plus 1 is a, x square plus 3x is also, 3x square plus 2x minus 1 is also. All these are the examples of your quadratic polynomial. Then trinomial. Trinomial you can understand 1, 2, 3. When 3 terms are there, but do not say 2x square plus x plus 3x will make it a trinomial. Like terms can be added or subtracted, and then this will be 4x and only 2 terms will left finally. So please keep a watch upon that. Unlike terms should be there in all 3 terms, then it becomes a trinomial. And then biquadratic. Biquadratic, I said the degree 2 you have to repeat, x square whole square plus, like you have written suppose 3x cube plus 2x, and it is not necessary even to write 3x cube. Directly you can write x square also or x also, then constant term anywhere you have left. So your example, you can write x raised to power 4 plus 1. This is also a biquadratic polynomial. If you have written x raised to the power 4 minus 3x, again is a quadratic polynomial. If you have written x square minus 3x cube plus 1, again that is a quadratic polynomial. Concern is with the power. Power should be 4 here. So where the power is 4, that power means degree of the polynomial when is equal to 4. Those all polynomials are put under the category of your biquadratic polynomials. So that is all about your question number 2. Then question number 3 was write the degree of, first it was x square into x minus 1 whole square. So you need to expand this. So this will be x square plus 1 minus 2x. So definitely when you will be multiplying, highest power will be 4. So here the degree will be 4. Then you have to, in second part it was 1 upon x square into x cube minus x4 plus x raised to the power 8. So everywhere you have to divide it by. So x cube upon x square minus x4 upon x square plus x raised to the power 8 upon x square. Here it will be 1, here it will be 2, and here it will be 6. So highest degree you will be finding is 6. So degree of the polynomial here in second part will be equal to 6. Because when the bases are same, we need to subtract the powers. So highest power in these three cases you will be getting is 6. So degree you will have to take 6. In third part, it was given 0. What is the degree of this 0? So I told 0 itself denotes a 0 polynomial, and the degree of 0 polynomial is undefined. So here I have to write the answer, that is not defined. And in fourth part, it was a constant polynomial. The degree of constant polynomial is always 1. In previous lecture, somewhere by mistake, I have called out the degree of constant polynomial. Somewhere I said is 0. No, that is always equal to 1. Constant polynomial's degree is always equal to 1, and degree of the 0 polynomial is not defined. Please keep a watch upon your answers. So how many correct are there and what are your difficulties? Please do correction of those also. Fourth was, which of the following are polynomials? Explain why or why not. Now first part was x minus 1 upon x. So your answer is no. This is not a polynomial. Why? Because when I will write, the power will be negative, which is not the part of the definition. Powers, whole numbers, 1 or greater than 1. So that is the contradiction here. Second part was x raised to the power 107 minus 1. So power is positive, base anywhere you see if x is there and power is positive, so I can write that as a polynomial. Then third part, y square minus 2y plus 3. Because this is there in the form of, you have to write the reason also. So why or why not? Because it satisfies power is more than 1 and is a whole number. So that is the condition. Here, yes, this is again a polynomial in one variable. Power is there, constant term is there. So constant terms can be there in third form also, not an issue. So again, this is a polynomial. And D part was somewhere it is y square minus under the root y. Again, answer will be no for this, because y under root will be expressed as y raised to the power 1 by 2. Again contradicts that power cannot be there in the fraction form. And finally it was 1. So 1 of course is a polynomial, but it is a constant polynomial, degree of which is always equal to . Then next, you check, verify that 0, 4 are the zeros of the polynomial. You have to verify for polynomial px is equal to x square minus 4x that 0 and 4 are the zeros. So okay, when it is case of 0, so this makes 0 square minus 4 into 0, 0 minus 0, that is equal to 0. The answer will be yes for 0. Answer is yes. For second part, that is P4, this is 4 square minus 4 into 4. Again, this is 16 minus 16 is equal to 0. Yes. So both 0 and 4 are the zeros. So verified. So simply what you have to do, in place of x, first you will be replacing x by putting it 0. And in second case, you will be replacing x by putting x is equal to 4. And check if the result is coming equal to 0, means it is verified. Then your sixth question was, find the zeros of the polynomial. Find the zeros of the polynomial. That was Px is equal to 2x minus 7. So procedure I have explained to you. 2x minus 7 you need to put is equal to 0. So 2x is equal to 7 and x is equal to 7 upon 2. So x is equal to 7 upon 2 will be the 0 of this polynomial. As soon as you will be putting this value 7 upon 2, it becomes 7 upon 2 minus 7, and 7 minus 7 will make it 0. So that's why 7 upon 2 will be the 0 for this. And second case was gy, any polynomial in terms of g. It was given is equal to 2y. So 2y when you will put is equal to 0, y simply will be equal to 0 upon 2, so 0. So y is equal to 0. So g0 will make it 0 only. So that is equal to 0. So 0 of this polynomial will be 7 upon 2 and 0 of the second polynomial will be 0. So please keep a watch. That was the assignment I have given to you at the whole discussion of your part before proceeding towards the next exercises. So you need to keep a watch upon what is the polynomial, what is the degree of the polynomial, and constant polynomial and zero polynomial. Please make those things very clear. Constant polynomial and zero polynomial. Do not get confused here. So constant zero polynomial simply is 0. Degree is undefined. Make it clear forever. Degree here is undefined. No need to write anything about that. And here if you are writing 7, suppose 7 itself is a constant polynomial. So no variable will be there. And if you are talking about the degree, so 0 exponent, 7 into x raised to the power 0, whatever the polynomial is there, I can write that in terms of 0. So degree of the constant polynomial will always be equal to 0. Why? Because 0 exponent is always equal to 1 and it will remain 1 only. So in any constant polynomial, whether that is positive or whether that is negative, I can put the variable in which the polynomial is given with power 0. Why? Because I know that 0 exponent is always equal to 1. So if any number multiplied by 1, so that identity will remain same. So this is the difference between the constant polynomial and the zero polynomial. So that's all about all 6 question solution. Today again you repeat your remainder theorem as well as your factor theorem that already we have discussed with you both the solutions, and then tomorrow I will proceed with the next questions of your exercise. Thank you.